Just I am recording. Yes, I told you about this. There is a rectangular Cartesian coordinate system. Rectangular Cartesian coordinate system, just like your x, y, z axis, x axis, y axis, z axis, you are aware of that one, which are mutually perpendicular to each other with an origin O. I can consider that is a coordinate system, which is rectangular Cartesian coordinate system. In that rectangular Cartesian coordinate system, here, that is said to be fixed somewhere else. I can consider that one as a rigid coordinate system. Using that rigid coordinate system, we can explain whether the body is said to be under rest or the body is said to be under motion. Whether the body is moving or the body is said to be under rest, or is it moving with a relative velocity which is equal to 0. I think in first year PUC already you are aware of the relative motion. Relative motion already you have come across. All these ideas we can explain by making use of a frame of reference. So therefore I can say that, what do you mean by a frame of reference? What do you mean by a frame of reference? A frame of reference is a rigid coordinate system. A frame of reference is a rigid coordinate system. Using that, we can explain the relative, we can describe, we can explain the relative motion of the bodies. The relative motion of the bodies. So what do you mean by that relative motion of the body? For example, if the body is said to be at rest, with respect to something else that we can consider. Let us consider this is a train. This train is present here. This is another train if it is moving like this. This is one track, this is another track. A train is moving like this. Here also a train is moving like this along the same direction. Here there is a train number 1. There is a train number 2. Both are moving like this. Now, let us consider if we are seated here, if you are present here, if you are observing this, both are moving along the same direction, both are moving with the same velocity, Therefore, even though you have seated here, you are going to see this train always. Therefore, for this train passenger, this train appears to be at rest always. For this train passengers, this train appears to be at rest. So therefore, we are going to say, with respect to this frame of reference, this is at rest. With respect to this frame of reference, this is at rest. Now let us consider a person who is standing on the earth. On the earth, if he is standing, if he is observing this also and this also, he is going to say, this is also moving, this train is also moving. With respect to earth, a frame of reference fixed to the earth means an observer standing on the earth, he can observe that both the trains are moving. But if you are considering a person, means a frame of reference, fixed to a frame of reference here, a train if it is moving, with respect to this train, this is at rest. With respect to this train, this is at rest. This is called by the name relative motion. But with respect to earth, this is moving. With respect to earth, this is also moving. So we are aware of that. Relative motion, you have to study. Take your own first PUC book. First PUC book, you take it, see the dynamics. Under that, you are having the relative motion. Just you go through that relative motion. Relative motion, you go through that. Okay, relative motion, relative velocities, especially relative velocities we require. Okay, without that relative velocities, in our day-to-day life also it is holds good. It is some occasion it is helpful for us. Okay, even in the case of a cricket field or some other whatever the sports and other things, the games, we require the relative motions or relative velocities. Anyhow, frame of reference is a rigid coordinate system. Using that, the bodies, whether they are at rest, whether they are moving, they are having a relative motion, all these ideas we can explain by using a frame of reference. There are two types of frames of references. Frame of reference. I will consider frame of reference. There are two varieties of frames of references. One frame of reference is called by the name inertial frame of reference. Inertial frame of reference. Second one is called by the name non-inertial frame of reference. One is inertial frame of reference, the other one is non-inertial frame of reference. So frame of references can be divided into two categories: inertial frame of reference, non-inertial frame of reference. Yesterday we have discussed this also, continuation that I am putting. What do you mean by an inertial frame? What do you mean by a non-inertial frame? In the syllabus, even though they have not mentioned about the non-inertial frame, we have to learn that also. Okay, we cannot learn only about this. Okay, little bit away from that one also we have to learn. What do you mean by inner? Because next future classes, maybe tomorrow, day after tomorrow, somewhere else, if I am taking up a derivation or something else, even for the non-inertial frame, I have to consider. So, what do you mean by inertial frame? What do you mean by non-inertial frame? Inertial frame means an inertial frame. It is a frame of reference in which Newton's second law of motion is holds good. It is a frame of reference in which Newton's second law of motion is holds good. It is valid. It is a motion, it is a frame of reference. That frame of reference in which Newton's second law of motion is valid. F is equal to ma is holds good here. Whereas here F is not equal to ma. Newton's second law of motion does not holds good here. Here Newton's second law of motion, it is holds good. Newton's second law of motion, it is holds good here. Yes, I think you are hearing my voice. Mamata, you are hearing voice, you are hearing my voice. Are you hearing my voice? Audio you are getting. Audio you are getting. Anita. Okay, yes, some of you are not getting because of your problem, that is. Yes, inertial frame of reference, non-inertial frame of reference. So now one by one I will going to consider here. What do you mean by inertial frame of reference? So frame of references can be divided into two categories. Again, if you want, I will write. This is frame of reference. This frame of reference, very good, okay. A frame of reference can be divided into two categories. One is inertial frame of reference. Inertial frame of reference. Second one is non-inertial frame of reference. Non-inertial frame of reference. So there are two varieties of frames of references. Inertial frame of reference, non-inertial frame of reference. Both are rectangular Cartesian coordinate systems only. Both are like this only. X-axis, Y-axis, Z-axis. Both are like this only, don't forget. Like this, X, Y, Z. This is taken as S frame. This is taken as S dash frame. Maybe X dash, Y dash, Z dash with O dash origin. This is S dash frame. This is S frame. S dash frame. Both are coordinate systems only, rectangular coordinate system. But in this frame of reference, Newton's laws of motion, especially Newton's second law, it is holds good. Newton's second law is holds good. If Newton's second law is holds good here, Newton's first law is holds good, Newton's third law is also holds good. Otherwise, I can write here Newton's laws of motion. Newton's laws of motion are valid. It is holds good. Newton's second law, if it is holds good, Newton's first law is also holds good, Newton's third law is also holds good. Either you write like this or you write like this, you will get 1 mark, no problem. Then such frame of reference is called by the name inertial frame of reference. An inertial frame of reference is a frame of reference in which Newton's laws of motions are holds good. Whereas here, Newton's second law does not holds good, which is not applicable here. Newton's second law, which is not applicable. F is not equal to ma here, but here F is equal to ma, that is holds good. Okay, F is the force, m is the mass, a is the acceleration produced by the body. A is the acceleration produced by the body whose mass is equal to m, on which there is a force that is acting, that force is equal to F. So therefore, if Newton's second law is not holds good here, if Newton's second law is not holds good, such frame of reference is called by the name non-inertial frame of reference. A frame of reference in which Newton's second law is not holds good, or Newton's laws of motion are not holds good. Newton's laws of motion which are not holds good, which are not valid, such a frame of reference is called by the name non-inertial frame of reference. Now let us take up between here and here the examples that I suppose to quote here. So which are the examples here? Example number 1 here. A frame of reference which is not at all moving. A frame of reference which is at rest, I can consider. So let us consider a frame of reference which is at rest. This is at rest. If a frame of reference which is at rest, that frame of reference where the Newton's second law is certainly holds good, therefore it is called by the name inertial frame. So give an example for inertial frame. A frame of reference which is at rest. A frame of reference which is at rest, I can call it by the name inertial frame of reference. Number 2, example number 2 here. A frame of reference, let us consider it is moving here. A frame of reference which is moving, a frame of reference which is moving with uniform velocity. This is most important here. Which is moving with uniform velocity, not variable velocity. If it is moving with variable velocity, it is non-inertial frame. A frame of reference moving with a uniform velocity. If a frame of reference, if it is moving with a uniform velocity, steady velocity with which if it is moving, I can consider that frame of reference must be taken as inertial frame of reference. That is an inertial frame of reference. So give an example for inertial frame of reference. A frame of reference which is said to be at rest, fixed one. A frame of reference if it is moving with a uniform velocity, that can also be taken as, an inertial frame of reference. Now going to the non-inertial frame of reference here. Let us consider non-inertial frame of reference. In the case of non-inertial frame of reference here, example number 1, I can say a frame of reference moving with an acceleration. A frame of reference moving with an acceleration. A frame of reference moving with an acceleration. It is a good example. It is a very good example for a non-inertial frame. For a non-inertial frame of reference, I can consider a frame of reference moving with an acceleration. Not only that, example number 2 also I can consider. A frame of reference which is revolving, which is rotating. Okay, I can consider a rotatory frame of reference. Any frame of reference which is moving in the form of a circular path. A rotatory frame of reference can also be taken as an inertial, non-inertial frame here, because a rotatory frame which is having an acceleration. A rotatory frame which is having an acceleration here, hence we can consider that one also as a non-inertial frame of reference. So now conclusion, whatever the concepts I have covered here, what do you mean by a frame of reference? A frame of reference is a rigid coordinate system. Using that, we can explain, we can describe the motion of the bodies. We can describe the motion of the bodies. How many varieties of frames of references are present? Two varieties. Inertial frame, non-inertial frame. What do you mean by inertial frame? An inertial frame is a frame of reference in which Newton's second law is holds good, hence Newton's laws are holds good, then such frame of reference is called by the name the inertial frame, in which I can consider examples here. If a frame of reference which is said to be at rest or a frame of reference which is moving with uniform velocity can be taken as an inertial frame of reference. Non-inertial frame of reference means where the Newton's second law is not holds good or Newton's laws of motion does not holds good. Example, a frame of reference which is moving with an acceleration means variable velocity. A frame of reference which is moving with an acceleration is a good example for non-inertial frame of reference. Another example, if a frame of reference which is moving in a circular path, a frame of reference if it is moving in a circular path here, that is a rotatory frame of reference, can also be taken as a non-inertial frame of reference. Okay, these are the two concepts that I have covered today. Little bit, one more line that I will going to consider today. One more line. What do you mean by Galilean principle of relativity? 2 marks question we are asking. This also we are asking for 2 marks. State Galilean principle of relativity. Galilean principle of relativity. State Galilean principle of relativity. We are asking for 2 marks. What is that statement? Very simple. If you are considering any laws of mechanics, all the laws of mechanics, you consider any law, all laws of mechanics, under that whichever the law that you are having, all these laws are having same mathematical formula, mathematical forms or formula in all frames of reference, in all frames of reference, in all frames of reference, moving with uniform velocity, moving with uniform velocity with respect to an inertial frame, If a frame of reference moving with a uniform velocity relative to inertial frame is also an inertial frame. Any frame of reference moving with a uniform velocity with respect to an inertial frame is also an inertial frame. Therefore, in an inertial frame, mathematical forms of all mechanics, F is equal to ma, S is equal to ut plus half at square, V is equal to u plus at, okay, then V square minus u square is equal to 2as. Whatever you have studied the basic laws of mechanics, dynamics, mechanics, all the laws of mechanics, they are invariant, they are not changing. All the laws of mathematics or whatever the mechanics, they are having the same mathematical forms. The mathematical forms which are not going to get changed. That is the law here. So what is the law or the principle, Galilean principle of relativity? All laws of mechanics are having the same mathematical forms in all frames of reference which are moving with uniform velocity relative to an inertial frame. If there is an inertial frame, already it is said to be existing here. If you are considering one more frame here, this frame, if it is moving with a uniform velocity, if it is moving with uniform velocity here like this is an inertial frame. If this is said to be an inertial frame, and this frame, if it is moving with uniform velocity with respect to this frame here, then in this frame here, all laws of mechanics which are having the same format is not going to get changed. formula is not going to be get changed. The mathematical formula, mathematical forms, which is not going to be get changed in this particular frame of reference, because if a frame of reference, if it is moving with a uniform velocity, that is also an inertial frame. Don't forget. In an inertial frame, Newton's second law is holds good. Here also it is holds good certainly. Therefore, all laws of mathematical forms of all the mechanics, all the laws of mechanics having the same mathematical forms in such frame of references which are moving with a uniform velocity with respect to an inertial frame of reference. So up to here you are supposed to understand the concepts. Okay. Tomorrow I can discuss something else also.